Hello. It's a pleasure to be speaking at this venue about my research related to my PhD dissertation. My name is Thomas Gilbert, and I am a finishing PhD candidate at the Center for Human Compatible AI at UC Berkeley. My talk today will be focused on one of the key problems that I explored in my dissertation research, which was this question of what it would mean to conceive of autonomous vehicles, not just as providing welfare to some consumer of the system in question, but actually as a form of public infrastructure in its own right. And so my remarks today will flow from my effort in my research to explore that thought experiment and what the implications of that are for how we should think about the ethics of artificial intelligence more broadly. In order to frame that, I want to start with this question of how it is that we should actually try to define good driving behavior. This audience might be very familiar with the notion of a trolley problem, basically this idea that the self-driving car will face some kind of choice of who to kill or what kind of accident to cause when such an accident is unavoidable. When an accident is unavoidable, how should the car choose to allocate resources or choose to keep some people safe at the expense of others? And I think there's a problem with those sorts of abstract thought experiments, which is that they speak rather narrowly to a deterministic conception of some situation or domain, such that there's this hope of coming up with a computable answer or solution that you can model deterministically, and how the problem being that it's hard to map those sorts of choices onto the often very complex socio-technical development pipelines that define how autonomous vehicles are actually being designed and tested and deployed. So these different modules in robotics, this notion of localization, in computer vision, problems of perception and prediction, and then finally questions related to how it is these vehicles should plan their actions and how control can be established within their environment are extremely complicated and really not reducible, I think, in any really interesting way to these very selective and crude thought experiments that many philosophers and AI ethicists have tried to use in order to make sense of these sorts of moral dilemmas. And so what my work does is take a bit of a step back and ask more broadly how it is that different notions of deliberation, different theories of what deliberation is, have come to prominence in the AI research landscape. So how it is that theories of rational decision-making, how is it that an agent, for example, should act under conditions of uncertainty, are understood to work in leading AI research labs, and what are the different visions entailed of what that reflection can look like. And in doing that research and in that empirical and philosophical investigation that I've conducted, I've then tried to take a step back and ask, how is it actually possible for us to be designing systems in ways that allow us as designers to ourselves deliberate about the domains of deployment in new ways? In other words, how is it that our own idea of how a given task or a given activity could be automated shifts our understanding of the activity itself, perhaps in ways that we might want, or that in ways that might be good for us to pursue? And so from that line of reasoning, my dissertation research took the direction of examining these different sorts of choices that the designer is faced with when they are going about the work of specifying either an AI model or really any part of the AI system that is under their purview from the standpoint of development. And so in particular, what my research has done is analyze these three different types of choices that seem to be analytically at stake in many of the AI systems that I've encountered or that are on the horizon and coming soon. One being the question of how it is that the features at stake in some environment can be learned or represented as some abstract parts of a model. Another being a choice about how to structure feedback between the system and the environment. In other words, how it is that the system is or is not able to draw on information from its surroundings as a guide for how to update its own behavior in the future. And then finally, there are choices about indeterminacies within the domain itself, the actual application. the human context of deployment. And by indeterminacy, I really just mean to refer to the merely possible relationships that a given AI system, which might be unprecedented, will have with the other types of systems, whether those are human, institutional, economic, cultural, that already are at work in that domain. And it's defining those relationships between these systems that the designer actually ends up being in a position to reflect on. And so by mapping out these choices, I'm actually able to apply each of those to the specific application context of autonomous vehicle development. So more concretely, each of these choices respectively maps onto this question either of how it is that the risk of accidents can be minimized by modeling features appropriately or extensively. Secondly, how it is that damage to infrastructure, the actual material roads at stake, can actually be minimized based off of how optimization is pursued. And then finally, how it is that risk of monopolization can be at least understood, if not itself minimized, in response to this question of indeterminacy. And I'll explain in more detail what each of these specific instances of these choices mean in the course of this talk. So this is the high-level kind of diagram of the dissertation as a whole, and what you can understand this as is a schema for understanding what the ethics of a given AI system actually amounts to, or what the normativity of it amounts to. And so specifically with reference to autonomous vehicles, what I'll be doing in the course of this talk is trying to unpack what corresponding mode of deliberation is at stake with respect to each of these choices, with respectively either about features, about feedback, or about the indeterminacy of the application domain. So I'll start with this problem of how to minimize accidents, how it is that the designer is used to approaching this question. And I have some examples here of how this problem of featurization, the problem of defining features, manifests in driving environments of all kinds, but more specifically with self-driving cars. There's a video on the left here, which has recently become popular on social media, which I'll just briefly play. You can see this is a Tesla autopilot that somehow sees traffic lights being spontaneously generated in the middle of a highway, which makes no sense. But the reason is that the car in front of it happens to have traffic lights in the bed of the truck that are just in the bed of that truck and just aren't turned on at the moment. But the image recognition system has misclassified them as traffic lights. The car is unsure of what to do and whether or not they should be obeyed. And of course, the reason it's confused is that the image architecture, in this case, the computer vision software, has no actual understanding of what a highway is or what kinds of objects it makes sense to predict or anticipate or not on it. And so there's a major problem of what are known as edge cases, where there are always going to be some objects or some features that are out of scope of the way that the model in question has been trained and deployed. And there's a risk then of giving it enough data and enough well-structured data that it's actually able to recognize the things that we want in a way that's reliable. And this remains a problem. This is a deployed system itself. And so this is one aspect of what designers need to think about. If you look more in the long term, there's an issue, and this is in particular germane to this algorithm of reinforcement learning, this problem of what's known as reward hacking, which is basically where the designer is in a position of specifying rewards for the system to try to learn and specifically form a policy in order to optimize. But if the designer has misspecified those rewards, there's a danger that the system will actually learn precisely what it was told to learn, but not what it was meant to learn, at least as it conforms to the actual stakes of the environment. I'll just briefly play this clip here. This has now become a famous clip of its own, where this boat was trained to basically maximize the most points, and that was taken by the designer as a meaningful proxy for winning the race against the other agents. And what you can see is that actually what it's learned is that it no longer cares about winning the race. All it cares about is completing this loop-de-loop, because that loop-de-loop of getting these turbo boosters happens to get it the most points out of any discrete set of actions that it could take. And so ironically, the boat is doing exactly what it was told to do, but it's not doing what it was supposed to do. And so this problem of misspecification, or in this case, reward hacking, is going to be one that I think is likely to become more and more severe as AI systems become more and more complex and are able to navigate more and more complex environments where more than one source of reward is at stake. And what this leads to then, my slides cooperate here, is I think an emerging paradigm for how the designers should be making these choices about how to structure features namely that the problem of how accidents are caused is likely to arise whenever there is some mismatch between the features that matter for a given task and those assumed or learned by the agent or model. Right now, we're already seeing this with discrete, like individual self-driving cars, such as Uber crashes or Tesla crashes. In the future, designers will be in the position of optimizing an entire traffic grid. An entire city grid will be something that's in the scope of their model, and they'll be able to control the flow of traffic at scales that have actually never been able to be intervened on before, even by a city planner, let alone by an AI designer. And so this risk is actually likely to increase going forward. What I do in the dissertation is try and present that risk as this emergent mode of deliberation, which I name as socio-technical specification. This problem of asking what are the essential features of a given task to be modeled or to be learned, and how are those distinct from the non-essential features? The ability to draw that line, at least so far, is only something a human designer can do. It's not itself something that an AI system can learn, and it's certainly not something a self-driving car can, of its own accord, be responsible for organizing for itself. And so this is what I call the first mode of deliberation at stake in this question of thinking of autonomous vehicles as a kind of public infrastructure, as something in the public interest, that there needs to be this deliberation on the part of designers about the features that are actually at stake in the application domain. And then secondly, I'll talk about damage to infrastructure. So this problem of feedback is probably most familiar to us now in terms of this dynamic of online radicalization, this being something on social media where people are shown more and more information that happens to conform to things that they've seen in the past or liked in the past or lingered on in the past. And the recommender system takes that as a signal to keep showing them that content or similar content. And what that does over time is redistribute people's preferences to change conceivably their worldview or their ideology or their sense of what is true or not true. And so whether you want to call that misinformation or radicalization, it's actually very important to understand that as a cybernetic problem, as a problem of feedback between, in this case, the user of the social media recommender and the recommender itself. And it's very important to structure that relationship in a way that is good. What my work does, because that's a known problem, is actually generalize that to the road environment and to the self-driving car problem space, particularly by looking at roadware as something that autonomous vehicle developers have to pay attention to. Because if your goal is to optimize the performance of an AV fleet through a given city, it is trivially the case that what it will learn to do is pick one highway or one road thoroughfare, one set of intersections, and just double down on that and only drive on that thoroughfare. And what that will do over time is erode that part of the road systematically differently than other parts of the city. And so in effect, what you're doing is causing potholes or other forms of damage to the road environment and intervening on the preferences of other road users in a way that is disproportionate and possibly highly unequal and unprecedented. And we should basically understand that as the same type of problem that we're already seeing at scale in social media. And so what I try and do in another one of my dissertation chapters is come up with a kind of a diagram for modeling all the different types of feedback that this new kind of AV transit system will have with all the other kinds of public infrastructure or public utilities that already exist, to argue that damage will be more and more likely to happen whenever sources of feedback between the system we're designing and any other activities are ignored or mishandled, which will generate unstable conditions. So rather than just the system being suboptimal, in fact, the system might be optimal according to some constrained or contrived definition, but it will be unstable because the dynamics of the domain have somehow been left out of scope or contorted to whatever the specification happened to have been in the eyes of designers. So there needs to be this more principled understanding of how it is that, however it is we're defining what good performance would mean for the system, that's not just sensitive to the operation of the system, it's also sensitive to the operation of all of these other systems that already comprise the application domain. So what I call this in the dissertation is normative cybernetics, this question of how do we preserve the structural integrity of the domain, rather than just create some kind of optimal solution to some discrete task within that domain or as part of some discrete activity. So cybernetics classically just referred to the science of feedback, the study of feedback, the study of the way in which systems are able to learn or be sensitive to external information and use that as a guide to update their behavior. Normative cybernetics has to refer to this more specific question of how should we structure that feedback? How should we reorganize the domain so that the AV system we're building is appropriately sensitive to the types of information coming from these other systems with whom it should have an effective and stable and prudent relationship, one that is collectively desired by stakeholders. And so what we call that in the dissertation then is this is the second mode of deliberation, specifically the intersection of how we think about feedback with respect to the choices that we're being faced with. So then finally, there's this risk of monopolization. I'll just briefly describe this, although it's very important and I think underappreciated. This problem of how it is that it's going to eventually be possible for private autonomous vehicle companies to build fleets that are safe and efficient and fair and accessible in terms of who can use these fleets, but that in so doing privatize and possibly wither away the notion of public space. So if you compare or contrast how many American cities are laid out to much older European cities, for example, many older European cities have these very large public squares near the center where only citizens can walk. And the reason for that is that public space is not supposed to have to be optimal. It's supposed to be something that anyone who's a citizen can use as they see fit with respect to whatever ends or whatever purposes they happen to want to use it for, even if that's spontaneous. And my concern is that as computation becomes more advanced, as data aggregation becomes more possible, as 5G infrastructure is rolled out, it will become easier and easier for companies to effectively privatize and optimize over the cityscape in a way that they effectively become the decider of how a given city can be organized, of how it is public space can be structured. When ironically, we should be doing the opposite. We should actually be using these systems to optimize against the factors that we want, and then liberate public space so that other stakeholders can use it as they see fit, even in ways that might have nothing to do with the fleet's own operation. And so what I try and motivate here, and this again is very germane to this notion of public utility, is that this problem of monopolization will happen more and more whenever a single company figures out how to privatize roads instead of designing AVs to support the public interest. The danger here is that it's actually going to be much easier at a certain point to privatize public infrastructure, to privatize the way in which public roads can be used, rather than to build these systems in support of some legacy understanding of what the public wants. And instead, what we should be doing is proactively investing in the public interest so that we even know what we should be optimizing these systems to do, how it is that we want certain kinds of road intersections to operate, what modes of efficiency are most urgent or most desirable, what should be prioritized or not. And so what I call this is this notion of machine politics as the final mode of deliberation, the question of what do we want roads and by extension cities to be, that autonomous vehicle fleets should actually open up that question. They should allow us to counterfactually reason about how else a city could be made to flow in terms of its traffic, rather than just allow us to better or more efficiently optimize against a legacy understanding of how the city happened to have been organized in the past. And so this is what I call, this is the final axis or the final mode of deliberation at the intersection of indeterminacy and the technical choices faced in specification. And so in presented in table form, I want to emphasize this point that there are these different normative problems that pertain to different aspects of development that's where these modes of deliberation are active. And in particular, I also want to emphasize that each of these modes of reflection correspond to a different type of human agent. So designers are responsible, and they should be responsible, and they should do a better job actually of engaging in socio-technical specification. But we also need domain experts, and in particular transportation planners, to take a more proactive stance with respect to normative cybernetics, tell us what types of information and what types of feedback are most warranted for these systems to be learning from. And finally, I think we need a kind of agent that actually has not existed before, and that is called into being by these new types of fleets that we're designing, which is a public utilities commission. I think we need to understand autonomous vehicles as a new kind of public utility or that we should at least be willing to engage in that thought experiment in order to conduct this final mode of machine politics, to ask ourselves, if we want this city to work in a completely different way than it's worked before, we are the ones to decide that, or rather we delegate that task to this commission, and its job will be to then hold companies accountable, whether that's in terms of liability or standards or specific thresholds of accuracy of the models they're building, because those are the ones that we as the public consecrate as mattering most for the future of the city in which we want to live, based off of how we might happen to live now. So with that, I want to thank you again for this opportunity to present my work. My contact information is here. If you're curious to learn more or read any of my published work, it's available on my website there. And you can also reach me on social media via Twitter. Thank you very much.